Hello, this is our 10th Ableton video, and we will be looking at synthesis concepts with operator. So we've got our operator from our instruments, and I've just duplicated a few of them. We can use them later. We'll be looking at our first area, which is oscillator A. But if we had, they're all on to begin with, but only one of them has their level up. Let's change that a bit lower. So sine wave, there's the wave types for this oscillator, and you can go through them and choose the harmonics. So you've got sawtooth, square waves, you can even use white noise and triangles. We'll stick the sine. The center section that we're looking at is sort of like if you click on the oscillator, it will be for the oscillator and it will show the envelope for that. But if you click on LFO and turn it on, then it will be, the center section will be related to the LFO. Same for filter, that will be for the filter, that envelope. And you can also look at this as well with it. And same for pitch, if we look at it. All these things are related for the pitch envelope. In the LFOs, you can look at you can use different wave types to modulate it by, and the rate is the speed of the modulation, and the amount is how much modulation it uses. So we go back to here, and I play a note. You hear the LFO doing its thing then. So you can change the tuning of the modulator by going on the fine and you can also do that with the coarse. We'll just change that back to normal. And you can also have fixed, so we'll just play whatever frequency you choose on every single MIDI note. So I just press 3 different keys, but it still sounds the same. Plays the same note. You can draw in your own harmonics, like that. It sounds funny, but you can do it. So we'll just play around with the envelope for this. And you can turn your velocity up, so when you draw in MIDI notes, it actually works with the velocity. So it's at 100%, so if you draw it in and change the velocity, it will work now. There's one sound. That's a bass. You can save that if you want. There's a preset here. Now it's in the library. We'll just save that. So that's one. And then you use a different one. Make a different sort of bass sound. So I still have the track record enabled for that one, but no one. So. Just turn the volume down. There's sort of, what would you call that, glockenspiel, bell sort of sound, which has more release and very short attack. You can also change the different things like the velocity can go back up. You can add an LFO to that, and then you have some modulation. So that's a bit much of a modulation. So the modulation. modulation C being used. So we make another bass sound, so that was one over here. If I'm in the right octave. There's one bass sound. So again, we change the release time. There's a nice bass sound again. There's that. And change the velocity on again. You can put distortion on there again. It's just things you can do. There's bass sounds. So here's another one. Here's a long attack, so like 3-4 seconds, and change the level to -12, so it's not clipping or anything. So you can choose our wave types again if you want, or just stick to the sine wave. So the oscillator uses the wave type to make sound. So we'll use a short attack. Sorry. So that's what we use. So we're going to look at using tremolo, the modulation of volume, and vibrato, modulation of pitch. So we'll start with the tremolo. So we turn our LFO on, and then so we've got the key parameters, which is the rate, which is how fast, and the amount, which is how much. And then we've got the sine wave, and like all the other wave types you can choose, and how fast they are, or you can have it syncing to the BPM of the song. We'll just stick to that now. So the LFO doesn't make sound, it modulates its carrier wave, which is the oscillator. It's got two states, which are positive and negative. It has its own envelope, and it has its two destinations it can go to, so destination A and destination B. You can give percentages of how much goes to each destination, which is here, right above destination A and destination B. By default, the LFO will modulate the pitch of all oscillators unless you change them or turn them off and on and change the speed. So that will, if you set the end to 0, it will make the LFO keep on going, so the end's at 0 is at the top. Now if I press it, the LFO will keep modulating until the release ends on the actual carrier wave slash the oscillator that we're using here. So that sort of just does it for the moment that it's being used. So that was the modulation. The LFO can change with less amount. And for more harmonics, you can choose the sawtooth, makes the sound different. You can create a more ambulance effect by modulating pitch. So if we hold this, it might make it sound more like ambulance. Let's see how that sounds like an ambulance. So we'll modulate something else. So we'll set the LFO so it has no destination. Modulation of volume. So we'll find it in destination B. So if we press on destination B, you can see all these. So we'll want to choose oscillator volume A. So if I hold it now, you should hear the volume change. That makes it sound different. So if we wanted to make that sound more like an on-off sort of thing, you change that to a square wave. To make the LFO keep going, again, change the N to 0. So if I press it once, it will keep going. If I hold it. It would work better if I had the release time a bit longer. So I only pressed it once. So that's it. If we set it to 0, sort of like no fades, and creates sort of a delay. So then modulate according to MIDI trigger if we're over here. So that's re-trigger. The LFO restarts at the same position it is from where it begins each time you trigger it. So if I press one note and then another, it will modulate it individually and differently. Whereas if I keep this going, as soon as I press the first note, it will keep going to the next MIDI note you play. Like that. So I'll just quickly make a pad sound. Sort of pad sound. See how it sounds. So the low, high, so that just means the rate for the low frequencies, which is 30 Hz to 50 Hz. And if I change that to high, it modulates the frequencies from 8 kHz to 12 kHz. So then I can do it to the sync. So that's to the rate of the BPM. Combining the LFO with filter on. The LFO has no destination if I turn this off. So no destination right now. We'll use the low pass filter and resonate. So its effect where the LFO modulates the frequency oscillator. So we'll click on filter, so it's on destination A. So now it's orange because I turned the filter on. Or if the destination A is being used already, you can go on and choose the filter frequency in destination B. So now as I do this, you should see. So you can see that working now. If I have the amount on a lot, you can hear the modulation of the filter cutoff going off. Now we'll use the pitch envelope. So we'll use the pitch envelope to try and get a good kick drum sound. So I'll go to this one over here, and I'll just get a new operator. So what we're going to do is set the loop thing to trigger, and use a sine wave, and put the sustain. And we'll choose frequency, the fixed one, so it's not actually using coarse or fine. It's just using the frequency in here. So you usually choose a frequency related to the song. So if you used a song that was in A at 440 Hertz, you could get that to A. So you choose 110 Hertz, or lower than that, but half of 110, so 55 even, if you wanted. So matches 55. So there's, you can already hear a kick drum sound coming from that. We'll go deeper into it. If you want to make a really punchy, attacky click, change the phase so it's on a higher or low crossing, because if you went into there, that would create a click. Whereas if it was like halfway in between, like there, it's in phase. But if we're at 25%, you can really hear the clickiness come out. So when you're in trigger mode, it ignores the note off message and uses the decay time instead. It's an easy way to have a simple envelope. If you want more attack options, one way is to use the pitch envelope. So we use pitch envelope, turn it on, has the destination set to the pitch of the oscillator that you're using. Destination A, volume. And then what you can do is just change the pitch envelope so it starts very high. So that's the initial. And peak, we'll keep it a little bit lower than that. It hasn't changed anything yet because we haven't turned the percentage of the pitch envelope up. So we'll turn the pitch envelope up. So that sort of sounds like it's coming from a Space Invaders game or something. Good. If you want a slow and long decay time, you might want to match the decay time of the actual kick that you've already chosen. So if we go here, we got the decay at 1.4. We might change that to 1.4. So that matches it, but that sort of suits it better. So I've already changed the phase, so it's got more clickiness. And now we can fatten it up by using a filter and using the shaper and adding drive to it. So we'll do it normal, and then there's the drive. It just gives it a bit more fatness. If you have the newest version of Ableton, you've got other options that will be more useful to make like the distortion sound. You can also just put a distortion sort of effect on, if I can find a good one. So overdrive might make it sound. So there, that just added more distortion and gave it fatness and more attack. There's one kick, percussive sound. If we want to get a snare sound, we use the same idea. So trigger, bring the sustain down, put that to me. Oh, we're on filter, I think. Oh no. So there's that. That's like the fundamental frequency for the filter. And then if we change that to white noise and turn the level up, I'll just turn this down first. And now we'll start mucking around with the envelope for this. And we've got to change it to trigger. So that sounds more like a snare drum. Okay, so this is our Ableton video on using collision. So we can use collision to make physical models of sound. The operator uses a combination of subtractive, additive, and frequency modulation for its synthesizer. But collision uses physical modeling, which is trying to emulate physical objects to make sound. So we open collision. It comes up here. The key areas in collision are the excitator and the resonators, which are, there's two. You can use them at the same time. So the excitator is what excites the instrument to make a sound. For example, plucking, or strumming for a guitar, or hitting. So that's this section. So you can see it says mallet, so that'd be more for a drum. Striking, attack sound. And if you use noise here, it's more of a blow sound. And then in the resonators, you've got the different sorts of material. So you've got beam, marimba, string, membrane, plate, pipe, and tube. If you have a short decay, so there's kick sort of sound, make it sound different if I go the stiffness down. Change the octave. Sounds more like a tom. Material, so if we go over here, the higher it is, the more metal-y sound. So that sounds like metal. Change the material low. Sounds more wooden. This synthesis is useful for making unusual sounds, more so than recreating real instruments, because you could just record that. If you go to hit, the high percentage is more high frequencies, so we've done it. Bring out more resonance sort of thing. Using membrane with a short decay is good for pitched instruments, like pitched drums. Less bright. So that you can go through lots of different sounds with them. As you add more noise, it sounds more like windy sort of thing. And if you turn the noise on, you can get, and change the material to a tube, you can get a tube sound. There's that, and if you turn the mallet on, it sounds you're hitting the instrument, or the tube. You can also filter off to bring out more of the resonant frequency that you want. That's about it. Yeah, there's the snare percussive sound, and we went through some marimba, like pad sounds, and flute sort of sounds. Thanks for watching.